Okay, so in this problem, we have a long truck with a constant velocity, and it's passing a 3-meter long car. So 10-meter long truck, 3-meter long car. 97 kilometers per hour is the speed of the truck, and then 80 kilometers per hour is the speed of the car. Okay, so the car is going slower than the truck, so eventually the truck is going to overtake the car. So, all right, we're not given a ton of information here, but we're definitely given enough to solve this problem. So the truck is this long, the car is this long. If we think about it as a point, we want the point on the back of this truck to end up, right, in front of this car. So the total distance that it's basically going to be traveling is going to be equal to 13 meters. So that's the displacement for the end of the truck to make it to the front of the car, okay? So that is the distance that we're looking at horizontally, okay? So the equation we're going to choose to use here, well, let's actually write out everything else we have here too. So I have two constant velocities. So I am looking at the initial velocity of the truck, but it's going to be relative to the car, right? So I'm going to take 97 kilometers per hour, right? Minus 80 kilometers, 80 kilometers per hour. Okay, so this is a moving reference frame, right? Because I'm just basically looking at how quickly the truck is moving with respect to the car. So in my problem, I'm just kind of pretending like the car is staying still and that this truck is just moving at 17 miles an hour until the bumper is in front of the car, right? It can work that way. Our problem will work out that way just fine, just because we're labeling this as, so we're looking at these two objects and their motion relative to each other, okay? So V0 is equal to 17 kilometers per hour. And then I have, so 1 hour is equal to 3,600 seconds. So I'm just going to convert these. And then I have, let's see, 1,000 meters per 1 kilometer. Okay, so if I multiply by that, I should be able to get the V0 in meters per second. And if I check my math here, 4.72 meters per second. Okay, so I have the initial velocity. So it's the initial velocity, right, when the truck is here before it starts trying to move across the car. Okay, so that's just how I modeled this problem. Right, so using this equation, I'm going to use x minus x0 is equal to v0 of t plus 1/2 at squared. Okay, and my goal in this problem is to find how much time elapses. Okay, so I'm solving for t. Well, one more thing that I know. So I have my initial velocity. I have my delta x here. Okay, I'll write that out. So delta x equal to 13 meters. And then I also have one more thing. Because I know that velocity is constant, I know that my acceleration is going to be equal to 0 meters per second squared. Okay, why is that? So if I take the derivative of velocity as like a constant, so that's what acceleration is, right? Acceleration is equal to the derivative of the velocity with respect to time. If it's a constant, if I have the derivative of a constant, say the number 2, right, with respect to time, that's going to give me 0. The derivative of a constant will always be 0, right? So that's why when I have constant velocity, I know that I do not have acceleration, because acceleration is measured as the change in velocity with respect to time. If velocity is just steady and it's not changing, I know that I have a 0 acceleration. Okay, it's just an aside there. All right, so let's plug in what we have. So this guy, so that's equal to delta x as well. So we have 13 meters is equal to 4.72 times time is 1/2 times 0 meters per second squared times time squared. Okay, so we know that we can cancel this end piece right here. So we'll go to 0, and then we're just going to have the rest of these guys. So we're going to end up with 13 meters divided by 4.72 equals t, which equals 2.8 seconds. 2.8 seconds. All right, cool. So here's our final results here for this guy. So yeah, that solved our problem. So we wanted to know how much time elapsed between when the front of the truck was at the back bumper and then the front bumper of the car was at the back bumper of the truck, and this is our final answer. We did that by looking at the displacement to try to get this point along the bumper to the front. We treated our initial velocity as just the difference between the speeds that the cars were traveling, because we wanted to know the movement of one just in relationship to the other one along a point kind of on the car, essentially. Okay, and then then we used this base equation here. We plugged in everything that we had. We plugged in our initial velocity that we found. We looked at constant acceleration, found it to be equal to 0, and then showed why that's the case. When velocity is constant, that acceleration is equal to 0. Then we did some algebra and solved and got our time here. And yeah, that should be it.